bustle of a city.
Right.
After living in Chennai for many years, I find it is extreme calm.
Right.
So we live in the first floor.
In the first floor, okay. And you are only about 100 odd kilometers away from Lucknow, right? 110 kilometers or something.
100 kilometers. Yeah, 100 kilometers. To reach Kanpur, the only gateway is Lucknow.
Yeah.
There is a flight. It's not straight from Chennai. Yeah, it comes via Bangalore and it is at extra expense.
Right.
And it takes many hours. So anyhow.
So you have been here for a long time now?
No, a month only.
Month only, okay.
Yeah.
Nice.
I was dodging last 4 years.
Okay.
Invitation.
But
about 4 months back, the professor really pushed me hard.
Okay.
Yeah. He was following up with me for 4 years.
So what do you teach there?
Now I teach engine design.
Engine design. Okay.
My specialization is engine design and engine testing, both in the field as well as in the lab, matching it to vehicles and solving field problems and production problems. So I have honed my skill in these directions.
Okay. And where were you based in Ashok Leyland? Which office were you working out of?
I was in Hosur. Our engine R&D was in Hosur.
Okay.
Some 12 years back. Then they shifted it whole hog. When I just left the company, they shifted it to Chennai.
Yeah. Near Ennur, right? I mean that they have.
Not Ennur, sir. It was shifted to Velivaichadi. It is across the backwaters.
Okay.
Yeah, there is a small village called Velivaichadi.
Velapanchavadi. I know. I've gone there.
Velivaichadi, yes. Yeah. It was founded many years back, maybe in 1985 or something like that, but people are reluctant to move. So they were managing in Ennur and Hosur. Hosur was a big establishment. Then they shifted to Velivaichadi.
Velapanchavadi, I know.
Not Velapanchavadi, sir, Velivaichadi.
Velapanchavadi, okay. Sorry.
Velivaichadi is somewhere near Ambattur.
Oh, okay. Yeah, okay. But I've gone there, but maybe I got the name wrong, but I think I've gone there.
Yeah.
Place. Yeah. I used to be ex-Ashok Leyland Finance.
Yeah, you told me that, yeah. We missed each other by about 5 years.
Yeah, okay.
I joined in 2002. And I survived that till 2011.
Okay. You're reporting to Sesh or something? Or
no, I was reporting to Mr. Natraj.
Natraj. Okay.
Natraj. And Natraj reported to Mr. Seshai.
Yeah, okay.
Good evening.
Yeah, Gomati, I mean, all over to you.
Yeah, this is Maithili, sir. Maithili ma'am, channel.
Oh, okay, I mean, the name is appearing wrong, I think then. Huh?
No, myself Gomati. And Maithili ma'am was.
Okay.
Yeah, ma'am, open the video, ma'am.
No, I don't know. Camera is not opening.
Okay.
Log in my mobile.
Good evening, Mr. Mohan.
That's the reason I was late. Somehow that is camera blocked or something is coming.
Good evening, Mohan. Mohanji, how are you? Good evening, Shankar.
Good evening, Chandran. How are you?
Yeah, fine, thank you.
I was just listening to your conversation with Dr. Pal.
Okay.
It was something very unique that he did.
Yeah.
See, people from the industry, they're so busy that they never get to put their knowledge together in the form of a book. They're always running around. But Dr. Pal, the last few years, he wrote some amazing books, all published by Springer. Okay.
Uh-huh.
And you can imagine how much of effort it needs to put so many years of rich knowledge into those crisp, condensed books. So he did that. And so I think that will greatly help him now when he's in academics, trying to teach this course to people who don't have that kind of a hands-on industry experience. Those books will make it very easy for him, actually, because he has cited a lot of real-world problems and root cause analysis, many such interesting things, all very real-world based examples in these books. So I think that kind of a transition from industry to academia is very rare. And this is very unique. So we have some of those books of his in our library. So amazing, just too good.
Awesome.
Ines, can we start? Ines?
Yeah, I suppose so.
Yeah, I think we can. Yeah, we can start the meeting, sir. Will people let them know?
Okay.
Yeah.
Yeah, thank you, Mohanji. I think I'll start off with my welcome address. Good evening, one and all. I take this as a privilege in welcoming today's speaker, Dr. P.A. Lakshminarayanan, ex-CTO, Simpson and Company, ex-R&D head, Engines, Ashok Leyland, and ex-senior GM, Kirloskar Oil Engines. Also welcoming today's panelist, Dr. Shankar Venugopal, Vice President and Dean, Mahindra Technical Academy, Mahindra and Mahindra, and author of the book, which we propose to release today, The Mobility Engineer 2030. And S. Ramachandran, Principal Consultant, Lead of Engineering and Manufacturing, Infosys Knowledge Institute, author of the book again, Mobility Engineer 2030. I also welcome the panel moderator, Mr. Chandran Krishnan, Managing Director and CEO, Campus Angels Network Private Limited. I congratulate, firstly, our Mr. HR Mohan, Information Technology, AI and IoT Committee of our chamber for organizing this joint book release and panel discussion in association with IEEE, ACM Chennai, and CSI, Computer Society of India. I welcome the governing body members of all the associating organizations and their members. I welcome all the office bearers, council members, and members of Hindustan Chamber of Commerce who have joined in this webinar. We have eminent speakers, and I'm sure we are all anxious to look forward and discuss on this subject and take it forward. By the way, I just want to say a few words on the chamber, sir. Our chamber is about 77 years old with around 975 members from various segments of the trade and industry. We are very active in the social media as well. And most of our members fall under the MSME sector. We all know that today MSME contributes more than 29% of the GDP and are responsible for 50% of country's total exports. They are all also accountable for 1/3 of India's manufacturing output. And today we are discussing auto and auto components related. I'm sure we must be, it should be a significant contribution that we will be going through. My company itself is a part of the logistics sector, sir. And at this point of time with EV coming in, the entire dynamics is changing. And honestly, I'm sure like many of us are very confused while taking decisions for when you want to make such capital investments of, augmenting your fleet and all those kind of things. I once again welcome all the speakers and participants for today's webinar, book release, panel discussion on skilling and business opportunity in connected, autonomous, shared, and electric vehicles. In my closing remarks, sir, I would just like to say that there are a few non-members as well of the chamber. I would ask them or request them to contact our secretariat and benefit from such activities and program. Before I finish my welcome address, I just want to share, since most of us are in this field, that on the 6th of February, we have a forthcoming program which is initiated by the Startup Committee. The topic itself is the power of AI and ML in ADAS, autonomous vehicles and electric vehicle. We have a speaker, very interesting, is one Mr. Parimal Modi, sir. He is an international consultant, automotive from France. So thank you very much and welcome you all once again, and over to our HR Mohanji. Thank you.
Good evening to one and all. On behalf of the organizing units, I would like to welcome all of you once again for this formal release of the book Vagana Poriyalar 2030. In English, it is called Mobility Engineer 2030. And following that, the panel discussion on the topic Skilling and Business Opportunities in Connected, Autonomous, Shared, Electric Vehicles. So in fact, we are privileged to have both the authors of this book present, along with two eminent people to participate in this event. One is Dr. P.A. Lakshminarayanan as a chief guest, who is an ex-CTO of Simpson and Company, ex-R&D head of engines Ashok Leyland, and ex-senior general manager of Kirloskar Oil Engines, who has got almost 45 years of experience in this automotive industry, and he has seen the industry from its infant stage to advanced stage of today with electric vehicles and so on. So in fact, we are privileged to have him as the chief guest to formally launch the book, as well as address the gathering on how the automobile industry had grown in the country and where we are heading. Basically, you will be touching the trends in the automotive industry. So following that, we will be having the panel discussion on the topic Skilling and Business Opportunities in Connected and Autonomous Shared Electric Vehicles. And for that, we have an excellent moderator, Mr. Chandran Krishnan, who is the Managing Director and CEO of Campus Angels Network Private Limited, having 40 years of industrial experience, including automotive, aerospace, and defense and financial services. So he knows the trend in terms of startups and then the creative minds, how they work in the new technologies emerging. And basically, he's going to drill the authors who have taken pains in elaborately written the book, over a period of, I think, almost about, it is a compilation of 25 chapters, which appeared on almost every week. Something close to about 6 months, they have run through this series in Ananda Vikadan. And he is going to really intricate and question them about the efficacy of these EVs and how it's going to be, trends are going to be in the future. So we are very happy to have both the authors of the book, Dr. Shankar Venugopal, Vice President and Dean, Mahindra Technical Academy, Mahindra, who is also the Vice President in taking care of the intellectual property at Mahindra Technical Academy. So he again has got a wide industrial experience in GE, Dow, Honeywell, and Cummins, etc. And currently, being the IP head, he is really looking in terms of new innovative products. And he's aptly joined with Mr. Ramachandran, who is the principal consultant, lead for engineering and manufacturing at Infosys Knowledge Institute, and in writing the book, which is very well appreciated by every reader. So in fact, Anand Devadan has compiled the version and then brought it out as a volume, which we are going to formally launch in our forum. And the other author who is joining is Mr. Ramachandran. He is the principal consultant and thought leader of in Infosys Knowledge Institute. He has got over 25 years of diverse global experience in market research, consultancy, and associated areas of manufacturing. He also co-authored one of the most widely appreciated book, Reskilling, titled New Skilling and Digital Transformation. In fact, both Mr. Ramachandran as well as Dr. Shankar have been with us with our IEEE, CS, CSI, and ACM in quite a few meetings, and they have interacted with our members and shared various aspects of industry as well as the trends. So, in fact, this is going to be a memorable instant for us in terms of discussing about the trends in the EV industry. And with this brief note, I would like to request our chief guest, Mr. Lakshminarayanan, to kindly address the gathering and formally launch the book. Over to Dr. Krishnan, please.
Good evening. Am I audible?
Yes, sir.
So, good evening to everybody. It is indeed a privilege to cross the bridge and then go to IEEE, which I have watched from a distance as a mechanical engineer for several years. I have read several papers that were related to engines, mainly in spectrum, not in the transactions, because transactions were too difficult for me to grasp. So spectrum was very interesting. So I was an avid reader for many years. And it is also, I think, the moment has come when both electrical and electronics engineers work very closely with mechanical engineers, and in turn mechanical engineers work closely with the electrical and the electronics engineers. I think the story of EV tells how this cooperation is taking place. Indeed, our departments at IIT Madras were just opposite each other. We were just divided by a small street covered by a number of banyan trees, so a walkable distance. So I spent a lot of time learning electrical engineering and electronics in those days. Electronics, especially from my elder brother, who was a professor of control systems and robotics. So I used to play with discrete electronic equipment, discrete transistors, ICs. Then we developed a number of instruments in those days which were not available in the market, especially to understand the engine. And then, of course, the byproduct was my PhD. That is another interesting story of how I was connected with the electronics. Never realized that I will find applications of electronics in engine. I began my career with mechanical equipment. Of course, I started from airflow, then fuel flow, then went deeper into hardware, etc. So over about 15 years, the companies made me well-rounded in design of thermal machines, thermal piston engines. I'll restrict to that. So I could foray into the future prospects at that time, mainly the electronic engines. People were afraid of electronic engines, but we were lucky to get trained in the institute as well as other establishments. So walking to this new unknown electronic engines was not so difficult. So we managed it. We could skill ourselves within 6 months and then manage it. But now the time has come that there is a direct challenge from electrical machinery to engines. So as a vehicle engineer, we have several challenges. Of course, understanding the microprocessor and building equipment using that. But the environment is developing, so it is very helpful. So there is not so much of fear as we expected a few years back. What will happen to the mechanical engineers, or what will happen to the electrical engineers, etc., etc. So we have now understood the electrical.
We have lost him.
Yeah, I think it's not audible.
1 second.
We'll wait for a minute. Yeah.
Temporary. So the
Wi-Fi is cut. Yeah.
interesting thing is we can, in effect, we can save up to 60% of fuel in the cities. So this is what will be immediately useful to the society. Of course, in the longer run, maybe by 2040 or 50, there will be sizable electrical vehicles, and possibly the IC engine vehicles will be a minority and may be left out for serving marine applications or large trucks and off-road equipment. Maybe for very small vehicles like scooters, motorbikes, or small cars, electrical vehicle would take over. So I just want to list some of the potential areas of research related to internal combustion engines in the next 10 years. As I just said, hybridization will be an important subject. We have found, for example, in the institute, IIT Kanpur, a hybridized IC engine vehicle would save more for the environment than a regular electric vehicle or fully electric, battery electric vehicle. Until about, say, 2050, when all the electricity will be available from renewable fuel. Today we produce from coal. So instead of driving it by policy, it will be more by being attracted to the vehicles. And alternative fuels are emerging, and in marine application we will have ammonia, and we will have more and more of alcohol replacing petrol for small cars or all the spark ignition engine vehicles. Emission reduction will be a topic that we cannot forget, because Euro 7 is knocking at the doors, and we will have more reactors as after treatment in the after treatment system, and tuning them with the help of advanced software and ECU will be the work. And we have to go for lighter vehicles because lightness brings down the fuel consumption. So we are going for advanced materials. There is a question about the future of internal combustion engine. It is much debated. There are two extremes. One would vouch the IC engine would disappear from the surface of the earth. The other one says, no, EVs cannot take over IC engines. But the truth is, somewhere in between. So the automotive industry is transitioning towards electrification, and IC engines are still expected to be around for a while. Today, whatever we have $93 trillion worth of, 58 trillion of internal combustion engine market, which will grow to 93 trillion in another 10 years with a compounded annual growth of 6%. So taxi engine has life, but it will be very refined compared to what we have today. Unlike what is predicted, that the IC engine will disappear by 2040, probably it will last till 2050. The trend towards electrification cannot be denied at the same time. We have several advantages of IC engines over electric vehicles. One is mature technology. We can manufacture high quality of international standard in India. The price of an IC engine vehicle is much less than a battery electrical, and we can power and manage and store data of IC engine vehicles, so no problem. One of the important advantage is the top speed. The electric vehicle cannot achieve the top speed as of today, just like a IC engine vehicle. IC engines have great handling. With the battery pack position in the center of the vehicle, it lowers the center of gravity. Okay, so providing superior weight distribution as far as the electric vehicle is concerned. But as far as the handling is concerned, IC engines are great to handle compared to electric vehicles. So the future of IC engine vehicles is there. It should last till 2050. But however, it is difficult to predict the exact portion of IC engine vehicles sold in 10 years, 20 years, 30 years, 40 years. But there is instead of predicting the proportion, we can predict the growth of the vehicle as per the demand of the market. But at the same time, because I have an IC engine background, I cannot deny the advantages of electric vehicles over ICE vehicles. The environmental effect will be, impact will be tremendous. But with the rider, when there is electricity coming from renewable sources. But today it is not effective. It produces more emissions on the whole during its lifetime than an IC engine vehicle. So hybrid may be a nice bridge for the next 15 years. Lower maintenance cost is claimed, but at the same time, there are fleet owners who claim EVs are costlier to maintain. But most interestingly, for a mechanical engineer, the powertrain is simple. The torque curve of a DC motor is ideal for a vehicle because it meets the demand of the vehicle perfectly. Unlike an IC engine has almost a flat torque curve, and this has got a hyperbolic torque curve, which is desired by the vehicle. So you don't need a complicated transmission box. Hardly we need 2 steps in the gearbox. So the gearbox becomes very simple. One step is to reduce the speed from very high to handleable speed, then another one to start. That is all. So two-step gearbox maybe is all necessary. And if it is a simple vehicle, we can forego with the two steps also. A simple single step reduction is enough. And just now we saw EVs have the lowest center of gravity because the newborn EV design has got a very low center of gravity. So whenever we are swerving around a corner, etc., we find the electric vehicles are more stable than vehicles with IC engine. Even though IC engines are IC vehicles are better, great to handle. Then the next 10 years, we will have software-defined vehicles, whether it is IC based or pure battery electric vehicles or hybridized vehicles. And, so software would play a critical role in the vehicle's functionality. This shift is driving global automotive players to augment investments into R&D and state-of-the-art infrastructure. Of course, electrification will be the direction because there will be a substantial market share for the electric vehicles. And this will continue, the market share would increase. India as a R&D hub is also preparing itself. It's emerging as a dream destination for developing new age technologies. Many global automotive players are expanding their research and development operations, particularly those in the software engineering and electronic domains in India. The country has a large pool of highly skilled software and electronics engineers, making it an attractive destination. And then lastly, the data-driven R&D is flourishing. Already when we went to Euro 6, we started logging the data from all the vehicles that are sold in the market. So when you go for newer vehicles, this data-driven R&D will become important, and somebody has to reduce the data which can be grasped by the respective managements, both the financial management, R&D management, production management, and even the top management of the company. So the automotive engineering faces some challenges. Disruptive innovation is one because the EV is on boil. Every day new development is coming up. We don't know whether lithium battery will remain in future or whether the cathode and anode will be the same as what we see popularly. We'll have new electrodes. Whether we are going to have liquid electrolyte or solid electrolyte, we don't know because so much of work is going on in the laboratory. And whether we are going to have lithium or cheaper sodium, we don't know yet. So this breakthrough might happen and stabilize in 10 or 15 years. So those who make investments in such technologies are somewhat holding fire in their hands. They're not very sure. So even large companies are afraid of putting money in different areas. Which one will succeed? They would not know. In data management, R&D teams have to conduct huge multitude of tests. Already we have so many tests when we are launching a vehicle or designing an engine. Now, with more computers coming in, the tests have to be many because you don't know which logic the computer program is going to enter in the field. So there will be a problem. And the electrification, of course, we discussed. Finally, software-defined vehicles. One example is, instead of having one motor, if you have 4 motors for 4 wheels, you can save 20% of the energy, because you can dispense with all the gear train, everything, and then control it. And you can make very small circles. You can accelerate quickly. So many things we can do, and run the motor at low speed instead of running at mind-boggling speed of 15,000, 20,000 RPM and getting into problems. But today we are afraid of putting 4 motors on 4 wheels, because we don't know if the computer that controls all these wheels will go mad sometimes. So we are still relying on the gears, which are proven over hundreds of years. So we are managing with the gear and with one motor to drive the rear 2 wheels. So if we are solving this problem of reliability of software, we can reduce the energy consumption straight by 20%. So that will happen, I think, in future. There are some disruptive innovations. There are examples. So there is a lot of future for automobile engineers to work on electronics, computers, and electrical engineering. At the time, put it in a nice mechanical box, and hence it is going to be very challenging. So this book, written by Dr. Shankar and Mr. Ram, is very special in this moment, because not only the automobile engineers, also the general public who are knowing partly about these vehicles are a bit curious. At the same time, sometimes fearful, sometimes with great expectations, want to look at the electric vehicles. Also, there was sporadic news items in India about the electric vehicles catching fire, because that has been disturbing people. But I would say the number of fires in India are very, very small compared to what is happening in China. In China, at least 2-3 vehicles catch fire every day. But India, I think, has done a great job of producing good quality vehicles. And in the last 1 or 2 years, even such bad news stopped coming. That means we are working towards an electric vehicle which is far, far safer than the big big production center of China. Why? Because I would have thought if the volume is very large, quality will be good. I think it is the sense of quality and the good workmanship that we have in India has enabled this important milestone, I would say, to cover. So we are in a better position than those companies. And our volume improves, I think the quality will further improve. And this book has come in the right moment, and it is written in a very simple language, both in Tamil as well as English. And this is a great exercise. I would have thought it will be back-breaking to write the story every week and then push it up to 25 weeks. It's a great achievement. These two, my friends, have achievement they have made. And I just go back in time. I just bumped into Dr. Shankar in the Indian Institute of Science many years back. We just introduced ourselves, and then slowly we became very thick friends. And I started knowing whatever research he is doing and my research and development he was knowing. We became very good friends. And after I superannuated from Simpson, I started interacting with Mahindra more closely at the MTA. And that academy is one of the finest which I have seen. I mean, with a vision, and actually they have a Bodhi tree in the academy. So I enjoyed teaching those young engineers there. And this story has been developed so that the normal person who is not knee deep in this automobile engineering can appreciate what is happening, especially about electric vehicles. With this introduction, I would like to launch this book as officially requested by Mr. Mohan. Thank you, sir, for this opportunity you have given. And you can go ahead, sir. Thank you, sir.
Thank you.
Thank you.
Thank you very much.
Thank you, sir. Thank you so much.
Thank you, sir.
Tom, you can also show the book.
Yes.
Yeah.
But I'm taking the picture.
Ah,
1 minute. I'm just taking a picture.
very good.
Okay.
Thank you, sir.
Very nice.
Congrats, sir.
Congratulations.
To you.
Thank you so much.
So now we can start the panel, sir. Thank you.
You want me to take over?
Yes, sir. Please.
Okay. Thank you. Thank you, Mohanji. Thank you, Dr. Paul, for a wonderful, enlightening talk. And congratulations to Shankar and Ram for the wonderful book they have written. And I'm sure that this is going to be great reading for a lot of people who can benefit from your book. And thank you very much for the opportunity, and a warm welcome to each one of you. I'm happy to be here on this occasion. Briefly, I mean, I myself am an engineer from IIT Madras, and I've done my management program from IIM Calcutta many years back. Got 40 years of experience after that. I basically have been a corporate career man, like many of you. So I have worked in, I mean, I mentioned about Hindustan Group, Ashok in finance, but besides that, I have been with HCL Technologies. I have worked with the CK Birla Group. I have worked with the Rane Group, and a long career where I had the opportunity to head businesses all over the world. I have acquired and I've been an M&A specialist. I acquired many companies outside India, UK, Europe, US, Australia, and also had the opportunity to grow companies from scratch. I mean, and basically, corporate life, has its own charm. And then I joined. I retired from Rane Group in 2017, and for a brief while I was freelancing, and then I joined Chennai Angels as a CEO. So last 5 years have been in the startup ecosystem, and I had, it's like virtually a second innings, and had the opportunity to be part of 60 investments at Chennai Angels, where I started now moving with entrepreneurs who are starting everything from scratch. Unlike a corporate sector where you have the opportunity to, you have a brand, you have people, you have infrastructure, you have systems, you have, resources. Entrepreneurs start with nothing. They start from scratch. They come with an idea and no finance support, and they have to start building a business from scratch. And so that is the kind of people I started interacting with, and it has been amazing learning. And I have, in retrospect, the kind of learning I have gone through the last 5 years, if I had some of this, learnings before, I think maybe I could have been a far different, in terms of the success I could have achieved in my profession. So I did this CEO job at Chennai Angels for about 3 years, and I went on to briefly head Shivnadar Incubation Foundation, the SSN Incubation Foundation in Kelambakam in Chennai, where I learned the art of building business. In incubators, you learn how to build business from scratch, and that has been a phenomenal eye-opener. And funding was not, in retrospect, funding was not that kind of a challenge. Funding means, are they solving a big problem? Are they having a great solution? Is the team good? Do they have some traction? Are somebody already funding them? Then you decide to fund. But building, I realized, was a different ballgame completely. Right from idea to idea validation, solution design, building a minimum viable product. I don't want to explain all this, but briefly, I wanted to touch upon this. In the product market validation, what channels to use, how to engage with customers, what revenue model, what pricing. So I realized it was a completely different ballgame. And in that context, I realized there is a big funding gap for startups, which are at a very early stage, where after product market validation, there are not many people who support. Angel network support only when they see 12 to 18 months of no revenue traction from startups. So that's how I started Campus Angels, and Campus Angels Network is now addressing the space. Incidentally, Shankar is also a member of, he's a member of eminence at Campus Angels. I'm fortunate to be part of this program today, to be part of the launch of the book. Now let me come to the subject of the matter today. And my own personal journey through the automotive industry has been a fascinating experience. In the mid-90s, I had the privilege of serving as the AGM business planning at Ashok Leyland Finance, a subsidiary of AL, and I led the strategy for the company, handled moving equipment finance, and then gained a unique perspective of the financial intricacies of the automotive world. Then I had the opportunity to collaborate with all major automotive earth-moving equipment manufacturers in India, understood the pulse of the industry from the financial perspective, and I realized the symbiotic relationship between finance and the automotive sector. Then in the late 90s, incidentally, a couple of days back, I realized Ram also worked in Hindustan Motors earlier. So I worked there from 98 to 2004. I continued my journey at the automotive industry in Hindustan Motors. I was general manager corporate planning, strategic sourcing. Then I became a chief general manager in marketing and sales for Mitsubishi vehicles, Lancer and Pajero. And that is a great experience which I went through. And fast forward into 2010s, I took on the role of executive vice president at in business development and strategy at Rane Group, who are the pioneers in automotive components. I led marketing services, M&A, and corporate planning. Had the opportunity to acquire a company in US at Kentucky, and also one company in Bangalore, which was into IoT space. And so got a good opportunity to understand more about the evolving landscape in automotive technologies. So with my background qualifications and and also this experience, I was fortunate to get some experience in the automotive industry. Apart from that, in Chennai Angels, I had the opportunity to be part of about 50 plus investments. I have been part of onboarding 20 startups for incubation at the Shivnadar Incubation Foundation. And I had the unique opportunity to evaluate at least 6,000 to 7,000 startups in the last 4 or 5 years. I'm in the panel of many incubators in their investment committees. And I'm also part of 8 and Angel Network. So that is my background. So let me move on. And to Mobility Engineer 2030, I look forward to gaining more insights from Dr. Pal Shankar and Ram, and we look forward to understanding their perspectives on the practical realities of the automotive world. So before we move on, congratulations once again to Shankar and Ram. You have done a great job in writing this book. It's a commitment to shaping the discourse on mobility engineering. And thank you for your exceptional contribution.
Thank you. Thank you so much.
Thank you. Thank you so much. And now let me move on to the questions. We'll make it maybe 3 questions each. I want Dr. Pal also to be part of this. So Dr. Pal, Shankar and Ram. So I'll start with Dr. Pal. Dr. Pal, what are your thoughts on how wide the skill gap is there for electrification of mobility, within what the industry needs and the talent pool which actually exists in India? And how do you think we can address that gap?
Yeah, I will look at it from my own background. The basics of electrical engineering are well established and well taught in our schools as well as practiced. Only thing is, when we were studying already, this kind of BLDC motor was in the way, was being developed in the laboratory, and many research scholars were working. So we had already a glimpse of what is going to come in future. Okay. So we had several kinds of motors being designed and developed and patented by the neighboring department, and we were aware of that. And one difference is those motors were running at relatively lower speed, whereas the motors in EV are running at breakneck speed, 15,000, 20,000 RPM, basically to generate more power in a small volume. So it adds to a lot of problems to mechanical engineering the rotor. The centrifugal forces or the stresses are so high, and we are worried about maintaining the gap between the stator and the rotor at extreme conditions, both due to temperature and due to the centrifugal forces. But of course, there are solutions to that. So these are possible to develop only in a well-established production line, not in the R&D. But we can are in the laboratories of the institutes. But we already have the reasonable background. Secondly, so this will be a small bridge we have to connect to the automotive field. The second bridge in scaling will be cabling. Consider in India, we are very horrible as far as cabling homes are concerned. Very, very poor quality cable. And I always fight or argue with our people how they connect, do wiring in the homes. But we cannot be so careless as far as EVs are concerned. We have to have a lot of respect. And especially when the voltage is going to be very high, of the order of 800 volts, 1200 volts, it will be very critical. So not only the skill, but also due respect, how to handle the things with great discipline. That has to be cultivated, both in the factory as well as while servicing. If they make a big mistake, the things can go wrong, and we will end up blaming the software, or we'll end up blaming the designer of the electric vehicle. And this is the skill I think we will have to do. And there are special skills also will be needed. Though it looks daunting in the beginning, Okay, it is like when I graduated from mechanical fuel injection to electronic fuel injection. For the first few months, I was very worried. But we can catch up. That's not going to be very difficult. But we can develop the skills by proper training. The engineers who are having sufficient attitude can be brought forth, and then we can give them training regarding the electrical vehicles. Of course, today, compared to what we had 20 years back, the electric vehicles has been reasonably blocked. We have block of motor, block of battery management system, and then the small gearbox. So once we master each of these blocks, I don't think it is going to be a great problem. So there is no need to be fearful of an electric vehicle. We have the environment for that, and by building small bridges, we can move over to electric vehicles without any hitch. But at the same time, we should be very disciplined and with some additional skill. That is all. I don't think there is a scare.
Thank you very much, Dr. Pal, and that is very comforting to know. And we can also see that most of the OEMs have been able to get their act together, and we are seeing good traction of sales happening, numbers going up, and thank you, Dr. Pal. Yeah. So I'll move on to Shankar now. Shankar, what is the cutting edge tech which you weaved into Bharat's journey? Did a specific engine or a battery or a breakthrough spark your vision, or was it a combination of various innovations that gave birth to this story?
Yeah, I think that's a very good way to start the discussion today, because the whole story revolves around somebody like Dr. Pal, and in our story we have named him Bharat, who is suddenly asked by the CTO to start a whole new vertical on EVs. So Bharat has years of experience in an IC engine-based system, and then suddenly now he has to learn and put together the very first electric vehicle product of his company. So when we started doing that, we thought which would be more important, building breadth for Bharat or building depth for Bharat, where we should start and how we should go about it. And we saw that the electric vehicle is not just going to be electric vehicle. It will also have connected features. It will have autonomous features. So we will start looking at the convergence of multiple technologies so that Bharat need not be an expert in any one of these areas, but he should know sufficiently about multiple technologies so that he can bring together the right mix and match of all these technologies. Of course, he had the advantage of some colleagues and collaborators who are deep domain experts. So as we go along the book, you will see him continuously going to them, having those deep dive discussions and learning specific technologies in depth from them. But Bharat by himself is more of a breadth person. So we looked at communicating to our readers how many technologies are evolving, and the two very fast, exponentially growing technologies, and how it's important for all of us to keep track of these developments and know a little bit about all these technologies. And then how these can actually converge together. And when they converge, they can change things just overnight. So we gave instances where Bharat started looking at innovations at the convergence of multiple technologies. So to answer your question, we didn't actually use any one specific technology, but kept bringing back that you should always look at combination of technologies. So for example, AI and IoT and additive manufacturing, those kind of combination of 2 or 3 technologies is what we always brought in as kind of ideas that Bharat was pursuing in his whole journey of building electric vehicle.
Wonderful.
And it's also easier for the audience because once we tell that this combination, then they can do their own reading to learn a bit more about. We also wanted to trigger that curiosity for the readers so they could always do that.
Wonderful, actually, Shankar, because I know that in my journey with the various startups, and where I see the entrepreneurs, they come with their brain and they try to put so many innovations together and try to build a business, and I think amazing. And I can see that bringing together different innovations and technologies together, and that is a wonderful way of putting it.
Just one point I wanted to add, Chandran. So Dr. Pal mentioned about having the right attitude and having respect and discipline. One thing that we wanted to convey through Bharat is Bharat has this beginner's mindset. He's ready to go and learn from anybody, be it a fresh GET or go to the university and talk to professors. He's always in that learning mode. And we wanted to say that is the most critical skill, because whatever we know today may not be relevant at all, maybe 3 years, 5 years from now. But your ability to quickly learn something new is going to be super critical. So we gave many examples of that in Bharat's journey.
Yeah, thank you, Shankar, for giving a great explanation of the how the Bharat's journey transpired. So now I'll move on to Ram. Ram, I think you're the business mind also here. So I'm looking at it from a different angle. So while Bharat was, looking at all these various technologies, how to put together, how did he, look at the market pulse? What is his, perspective from the market side? Consumer preferences or costs or regulations. Can you share some story on how he navigated the business side in his journey?
Sure, Mr. Chandran. Very interesting question that you brought up. So Shankar spoke about a lot of technologies, but in the back of his mind, Bharat was very much aware that it is not only technology which is going to make his business successful, because he was no longer an engineer manager. He was slowly graduating into a CTO type of role with financial responsibilities, right? So he knew from his experience that there were many technically superior products which did not become successful. So he had Tata Nano, for example, in mind. He had the Simputer in mind. The Tata Nano, as you know, had very good intentions. It met all its targets, both financially and technically. But we know what happened to it. All of us felt very bad about it, being auto enthusiasts. Similarly, the Simputers, we have spoken to Professor Vijay Chandru from ISC. Some of these products were ahead of time. So, as we say, consumer or customer is the king. So, Bharat had that very much in the back of his mind. So, one methodology that he wanted to practice, that he wanted to make very popular in his team, in his company, was design thinking. So design thinking, as you know, it is like a 3-legged stool, right? The 3 legs are, first is technical feasibility, where he was very confident. He had a PhD from Ivy League college, and he had amazing experience on the technical side. So he was very confident that Shankar spoke about the combinations of technologies, because electric vehicles are still a new product. Financial viability part, his CFO will be behind him if the product is not profitable. So he made sure that he had the cost under control, what was going to be the price on which it is to be sold. He had some interesting business models there. But the most important part was the desirability part. If you look at, again, going back to the Nano and Simputer type of examples, many more examples in US also. So he wanted to make sure the product was desirable and the consumers' preferences are taken into account. So for that, what he did was, Pawan and Kavya are 2 students, like his mentees. They had a lot of respect for Bharat. So he made sure they ran a survey with customers to really get the pulse of the customers. So I'll give you one example which came out of that. So traditionally, what we think is that electric vehicles should have a long driving range. We say range anxiety, right? But he was very clear. He wanted to segment it. All electric vehicles are not the same. So he thought of one category, for example, which is electric vehicles used inside urban conditions, for example. You don't cross a city. So there, his counterintuitive thought from his study among consumers with Pawan and Kavya's project was, it is okay to have electric vehicles with shorter driving range. So that was one consumer preference, one consumer insight that came out of his study. So he said we will have one category of electric vehicles which will have very limited range. So like Dr. Pal said, its weight will be less, it will be easier to control the vehicle. So design thinking was one approach. He wanted to he trained his team. He wanted that to be popular in the company. That's one point. Me and Shankar, both of us are very passionate about design thinking, like many of you on this call. So I think that's a practice which our students or professionals should be aware of. And then plus he also brought in a few more popular methodologies like QFD, for example, quality function deployment, where customer needs are mapped to product features. So this was an approach which was very popular now recently because of the chip shortage. So many vehicles, specifically in US, had many functionalities which were not really required. Customers did not use many of these hi-fi features beyond the first 30 days. Right, there was some initial hype; they never used it. So chip shortage drove the auto industry in US towards frugality in the vehicles, but Bharat wanted to follow that. So start with design thinking to ensure technical feasibility, financial viability, customer desirability to come out with good products which met customer needs. Use tools like a QFD to make sure every feature on a product really maps to something a customer needed so that the product is successful. So those are some ideas which Bharat followed to make sure consumer preferences are addressed.
Okay, thank you, Ram. And you are describing actually an ultimate entrepreneur. Where he seems to have had all these qualities. And thank you for explaining this. And looks like Pal seems to have line seems to have dropped off. So Shankar, I'll move on to you. Okay. So Shankar, I mean, the road to going from proof of concept, getting into prototype, and then getting into production is a very long journey and very bumpy also. So in Bharat's journey, where does he bridge the technology? I mean, whatever technologies he's looking at, and the real world application. And how did he give an example where he was able to turn an idea into a practical solution which could hit the streets?
Sure. See, when Bharat started this whole EV project, like any traditional technology leader or engineer, he tried doing everything himself. He wanted to solve every problem himself. He wanted to have all in-house technologies and solutions. Then you can imagine he was really struggling and it was just impossible. But he was not ready to accept that he can't solve all problems. And he was in that kind of a very messy situation at the early stage of his journey. And Dr. Sharma, who is the CTO, observes that and one day just talks to him late in the evening about looking at collaboration as a way of problem solving. In the sense, not just collaborating with people whom we know, but can you really bring in open innovation, where you take a small part of the problem that you're trying to solve and put it out there for the whole world to look at it, thereby crowdsource ideas from anywhere in the globe. Okay, so that was, of course, Bharat had heard about it, but he never thought that he'd be looking at it seriously for solving very specific engineering problems in his own domain. Being a trained engineer, he thought he should be solving it, but he never thought that he can actually outsource it. But that turns out to be the real way in which he was able to meet the deadlines and get a product out quickly by not trying to invent everything there itself, but leverage all the good ideas that are already out there. And one specific instance is customers. Ram talked about the range anxiety. Customers are so used to filling their tanks and then driving forever without worrying about getting stuck somewhere. But with EVs, that's not possible. So initially, the companies also thought we should put a very big battery so that it will give enough range so that this anxiety will be taken care. But in one of the brainstormings that Bharat has with his young engineers like Pavan and Kavya, One is a counterintuitive idea that comes up, is to say, let's go for small batteries, not the big batteries. And like everybody is totally zapped. What is this? How can it make sense to have a small battery? Then they go on to develop the whole concept of achieving a real world need with a small battery, because a bigger battery will add to the weight and also to the cost, but they kind of challenge the assumption, do it the other way around, and quickly go ahead to do a few that this idea may actually take them forward. So there are small instances spread across the story where Bharat actually does some out-of-the-box thinking, makes some bold decisions, and quickly does a quick and dirty proof of concept to convince the team that this is an idea worth pursuing. There are 5 or 6 such examples that we have scattered across the book.
Oh, that is awesome. I mean, all-round innovation. I think all types of innovation have been covered in this story. I mean, this is awesome. Awesome. Thank you. Thank you, Shankar. Looks like
Yes.
Dr. Pal is back.
Yes, I saw a note that he's connected.
Yeah, I know. I see him in the guest list.
Yes, I could hear him.
Yeah. So, Dr. Pal, I mean, I ask this question. I mean, I hope you are on the line.
Yes.
So, see your role as I mean, as CTO, I mean, equivalent in Ashok, Leyland, Simpson. I mean, it involved engine design, right? Engine design and development, and there is a need to adhere to the industry standards, so, but innovation would have also been needed. So, in a highly regulated, environment, did you look at innovation? Can you share any instance where you had to resort to that despite the strong regulations? And can you talk of an example? Is he there?
Unmute, sir.
No, I think he's on mute.
Unmute.
He's there, but we can't
yes.
hear him.
Yeah, he's there.
Yeah, now okay.
Yes.
So, when you said about standards, I just recollect some interesting thing that happened in my company. The idea of ISO quality standards was posed as a monster by many of my senior colleagues. I just joined the company, and they instilled a fear among the subordinates that if you do some mistakes during the audit, we will lose the certification, and the top management will pounce on us and then finish the department. And I saw in the first year, they were almost declaring a holiday for 15 days and before the audit. And there used to be a flurry of papers flying here and there and getting signatures with a kind of fake document prepared. It destroyed the basic need for such a standard. So I said, we are writing a lot of fake documents. So many signatures are being taken, and young people will run from one section to another section as if they have done a job with a lot of imaginary data. And during those 2 weeks, no regular or useful work will be done. The department will go quiet. Okay, the labs, design, everything will go quiet. And despite this, on the day of the audit, it used to take 12 hours for them to answer simple questions. They will rush to their table, bring some file, fill in. And I found the whole thing was very funny, and it was going against the principles. So what I said was, I will stop giving this holiday 15 days, and they should do regular work. Then my senior colleague said, you are going counter to the culture which we have been practicing for 15 years, and you will bring down the department and its name. Then As I said, when I came to the helm, I put an end to it. That is, in the first 2 months I faced this drama, I said no more. And there was a lot of complaint against me. I put those ISO 8 steps in folder form. For every project, this folder has to be filled in then and there by the project leader. In fact, I created a team which will be not for ISO. For any project, there will be a team, and the project leader can be a junior, and in the group, there may be a senior as a member, and in another team, there will be a senior as a leader and juniors as team members. Anything, depending upon the expertise, I created teams which was almost flat. It flattened our organization. So the young team leaders were able to fill in then and there all the letters, certificates, test results, milestones, etc. And if it is finished, if the 8th step is finished, the project is over. Then we will go for, that includes field trial. So everything was up to date, and when the auditor comes, he will ask, and we will open the computer and say, these are the projects. And they said, you should not expose all the projects. You should expose only 3 projects to the auditor. You have 15 projects, all should not. I said, nothing doing, all 15. And the auditor would select and then say, where is this? Then this fellow would click and the particular folder, and things will open up. And what used to take 12 hours was finished, believe me or not, in 1 hour. So that was one of the achievements I made. And the auditors said this should be replicated in other departments. And with the computer in front, the audits, as I said, were finished in 1 hour and with flying colors. Not that there were any points. If there were 1 or 2 points, we either answered then or by the next day. So if it can be made a way of life, the standards save a lot of energy and time, plus it brings in a lot of discipline in our work. It is not only the ISO, other standards also. For example, flow measurement, engine testing. We had standards. For engine testing, I had 82 standards. They have to go through those steps and then show the results in the folder. It will be in the ISO file itself. So I can open it from anywhere and then see that. So this made a tremendous change. In fact, people were very distressed in the department. There was a lot of attrition, up to 30% attrition. That means there were 60, about 20 will leave the company every year. So after I made these people own up all the standards, follow the standards, and then display the results. If something went wrong, they will write, so many tests were done, 5 only were successful, and the successful data will be in the data bank. And the attrition reduced to 1%. And our strength went from 60 to 140. So, wow. So we followed the standards, and it instilled a lot of discipline. So this is what I wanted to say. We should keep great standards, and if the standards are not complete for our requirement, we developed our own company standards.
Very, very interesting perspective, Dr. Pal.
Yes, sir.
Yeah, thank you for your insights.
Yes, sir.
So I'll move on to Ram. I want to see, you can see that, the Mahindra's commitment to lifelong, learning, it echoes in Bharat's journey. Okay. So does he encounter a mentor or an experience that pushes him outside his comfort zone? I mean, increasing his leadership skills and preparing him to take up bigger challenges?
Yes, Mr. Chandran. So, Bharat was very clear from the beginning of his career that the mentor-mentee relationship will be of great help for him. So, he was a hardcore mechanical engineer, like Dr. Pal said. So, initially, when he wanted to try out a new idea of using sensors to collect data, because, like Dr. Pal said, he was very clear that electronics and software can be used to increase the efficiency of internal combustion engines. It may not match that of the four-wheel vehicle. He's not the electric vehicle, but he was very particular that digital technologies can be used to improve it. But he faced some challenges in getting the data and analyzing it. So that's where Mr. Ravi, who is the head of quality in the company, he helped Bharat to understand whom to approach, right? And that was his first mentor. But throughout his career, Dr. Sharma, like Shankar said, has always been his mentor. He was the CTO for the parent group. He believed in succession planning, so he gave all the necessary training required for Bharat. He made him face situations at the same time. He was always there to help him when he faced any issue. So this mentor-mentee, at the same time, Bharat also made sure he had mentees. He mentored the students like Pawan and Kavya. He was very particular that he had to bridge the gap between the industry and the academia, and internships and mentoring students was something that he was very particular about. So he religiously followed it. He was on both sides. He had good experience from his mentors. At the same time, he also made sure he brought students up to speed. So that's something very significant. You can call it a soft skill. This is again beyond technologies that we have stressed a lot in the book.
So thank you, Ram.
We can just
really
add a quick point here, Chandran. So when we say mentor, we always think of somebody who is senior to us, elder to us, with more knowledge, and that's a common conception. But in the case of Bharat, here, apart from Dr. Sharma, who is actually much more senior with wealth of experience, the other mentor was Professor Murugan, who is his batchmate, his own classmate, but he's in academia, not in industry. The other mentors were Pawan and Kavya, who were very young GET engineers who joined working with him. So kind of Bharat was open to learn from people of his age group, people younger than him, people elder than him. So he looked at opportunities to learn from all kinds of people all around. So those shades of mentoring from different kinds of people through different kinds of interactions also is something that we brought into the story.
So he had growth mindset, and he was ready for intentional learning. So it need not be only classroom learning. He was ready to learn from multiple sources.
Fantastic. I mean, I'm seeing so many dimensions of, an organization has been covered in this. So I think, considering the time, I have one last question for Shankar. Shankar, I mean, you are a materials expert, I know. So does Bharat explore any unconventional materials or engineering methods to solve challenges? Can you share any moment in this book where he thinks out of the box and incorporates new materials or methods? Like, I mean, you have this bamboo composites or a 3D printed components or to achieve a breakthrough. Does he do anything like that?
There are three very specific instances where Bharat does something like that. He is very focused on ensuring that the technology that he develops is sustainable. So he doesn't want to really take any risk on any material that is not environment friendly. So he actually actively looks at alternatives for battery materials, alternatives for the materials that goes into the magnet of the motors. So wherever there is a possible threat to the environment, he pursues alternatives and newer technologies. So the third is, he also realizes that just by increasing the battery size, he can't increase the range because the battery weighs a lot. So he has to look at lightweight materials to overall reduce the weight of the vehicle. That's where he starts looking at composites like this bamboo-based composites, other natural fiber composites, so that overall he can reduce the weight of the vehicle. So since I have a background in materials, I was kind of tempted to go a little extra and talk about a few materials. But incidentally, in the case of EVs, materials do hold a very, very important role in terms of making sure that EV is absolutely sustainable. And so we have at least 3 instances where Bharat pursues a material-based solution as part of his innovation. Yeah.
Yeah, looks like no dimension has been left out.
Now, one quick correction I wanted to make was this was actually a series of 25 articles written over a 2-year period. This was not a weekly, but it was a monthly. So we had a lot more time to actually 3-4 iterations, and then initially we'll write in English, then translate to Tamil, a lot of work. So we had 4 weeks time for each of these essays. So these 25 essays were done over a 2-year time period and then came out as a book. So we had more time actually.
No, I understand, but
yes,
you have covered entrepreneurship, you have covered innovation, you have covered incubation, you have shown, building product and product market validation. You have talked about growth, you have talked about scaling. I mean, all these dimensions have been covered, which is awesome. And wish you all the very best for the success of this book, both Shankar and Ram. And I think I wanted to keep my questions within 7:25 p.m. so that we have 5 minutes more to close the session.
In fact, they have covered a new business model, battery as a service.
Yeah. Yes.
Yeah, that is another thing. I mean, so extensively they talked about cyclic. Circular economy.
Clarity.
I think in fact, it was looking like reading a management book for me. So when I read, being an automobile, basically a mechanical engineer, when I started reading the book, I felt more of a management-oriented concepts have been, and including the industry academia interaction by bringing Professor Murugan, something which they have very well thought of, and of course Pavan and Kavya, the younger generation. I mean, there are some side stories also there. I could relate that, including the last concluding remark. So it was. I mean, it is. I think we should take one episode of the video of this book, maybe in half an hour. I think you can think of doing that, and that will have a impact. That the impact of that will be really great. This the story is worth it taking as a movie. Particularly for, no, I'm not joking. For budding engineers, that will make a lot of sense.
True.
See, I mean, the story when you read, and particularly when Tamil, the people are not able to understand Tamil, so they may find it difficult. Of course, you are going to come with an English. Even then, the visual impact of this story, if you can take it, I mean, I'm just giving a wild thinking. Half an hour episode, if you can work out, that will be really great.
It will reach more.
Yes.
Yeah, that's right. I think this can make actually a big, I mean, there's all content available here to make it into a successful movie. And at this time, because next 5 years is going to be all about mobility engineering, and this may be the time. I don't know who will be able to, invest and, make a movie. I think you should float this idea. I think it's a great idea.
No, Vigadan can do it also, if because they have the provision. Or we can always crowdsource it.
I think that is assignment for you, HR Mohan.
Yes.
Yeah, we can do that, sir. We'll definitely. No, because when I read the book, I was only mentally, I was thinking, I was trying to connect it with a sort of a movie episode, something like that.
Yeah, very nice. So I am done. So any closing words or any questions somebody wants to ask, or Mohan, you can take over.
Yeah. No, basically we are just wanted to check. So because by 2040 we expect the IC engine vehicles will be likely to go out of market. What happens to the inventory? I mean, the people we have been using, and there are still millions of IC engines is going to be there. So what will happen to them?
Scrapped?
Scrapped.
I don't know. Shankar,
will there be any decline in the production in another 5, 5 years or something, they are going to reduce. Whereas I see that a lot of companies are expanding their production line. So there seems to be some sort of anomaly. We are talking about totally eradicating these IC engines by 2040 or maximum by 2050. But still, we keep on increasing the production capacity. So are the public is going to be at disadvantage?
I think the question for Shankar, I think.
Sure, that's a very difficult question to answer, honestly. None of us have a very precise answer for that. But what is also interesting is the way EVs will be manufactured will be fundamentally different from the way IC engine vehicles will be manufactured. You don't need that kind of a large plant because EV is very modular in its design and it's more of assembly and integration. So you need a much smaller space and more of robotics and stuff like that to assemble an EV. So the whole game, everything that you thought about the automotive industry, whether it's design or manufacturing or taking the product to market, everything is changing. What we have not talked about here is also the shift from individually owned vehicles to shared mobility and stuff like that becomes another dimension of disruption. So we have to just wait and watch because a lot of things are changing all around us. But one thing that we have to be ready is look at possible future scenarios and be ready. That resilience is very critical. So based on what happens, we should be able to quickly respond to that. So I think we should move away from that. This is what the future is going to be and this is my strategy. Should move away from that and see these 4 possible scenarios are quite possible. And if scenario A happens, this is what I will do. If B happens, this is what I will do. That kind of approach, I think, is what will make us successful in this new scenario.
Yeah,
another thing is regarding the flying cars. What happens,
Sure.
we are along the way, I think. Are we?
Yeah.
See, people are seriously looking at small electric airplanes, which are 6-seaters and 8-seaters, and that is quite possible. So, and that we have a good number of airports, very small airports in small towns across India, which are not being sufficiently utilized. So that you will see that happen. Next 2-3 years, you will see these electric aircrafts, which are 6 or 8-seaters, really flying across different cities in India.
Wow. Awesome.
Yeah, that will surely.
Yeah, Akila, can you just
Yes, sir.
read out? Yeah, please.
Sir, a very nice discussion we had, and we all were very interestingly listening to that. We have some few questions while registering the participants have asked. So I'll just ask that. First question, how India, particularly urban cities, can adapt traffic-less transportation system like metro?
I think electrification of public transportation is going to be very important for a country like India. So in one of the book chapters, we also talked about multimodal, where basically we'll be using different modes of transportation to go from point A to point B. Some of it could be through something like an electric train or electric bus. Then comes the last mile connectivity, which could be an electric cycle or electric 3-wheeler. So for a country like India, I think one should look at multimodal. And this is very important, not just one vehicle, which will take you all the way from doorstep to doorstep. So if you look at the government's approach, phase 1, they are looking at shared mobility providers going the electric way. Phase 2 is public transportation. And phase 3 is when individuals like us will make up our mind and shift to electric. And by then, the charging infrastructure, everything would be in place. That's how typically the government is also looking at this space.
And just to add to what Shankar was saying, how important micro-mobility is. So World Economic Forum, for example, considers micro-mobility as the future of urban mobility. And one very interesting development, in New York City, they have recently formed a department for sustainable delivery, because we see all these small micro-mobility 2-wheelers going around, right? All your Zomatos and all your delivery vehicles. So micro-mobility, like Shankar said, is going to be a very important part in the future of mobility. And that's what World Economic Forum says. And New York City has very interestingly formed a department for sustainable delivery, which is focusing on last mile mobility.
Thank you, sir. Next question. Please explain the advantage of hybrid vehicle and disadvantage of electric vehicle.
I think Dr. Pal would be the right person because the question is worded very carefully. Advantage of hybrid and disadvantage of electric. So Dr. Pal would be the right person to answer this.
Today, the all electric vehicle does not make sense as far as the environment is concerned, because we get almost 70% of the electricity from coal, and the total calculations show that it is the environmental impact is not very nice, as well as the manufacturing of batteries. They seem to be offending the environment. Of course, it should not stop us from moving to electric vehicles in the far future. Maybe we will have slightly heavier sodium batteries, which are more environment friendly, and by that time we would have installed a lot of renewable energy sources and methods to save the energy when it is produced in lot of more than required amount. We should save it in storage medium. It might be flow battery or pumped storage or compressed storage. In India, such plants are coming up. Then this electric vehicle will make really a lot of meaning, both in terms of cost and being friendly to the environment. But today it is not so. Whereas hybrid vehicle, if you work a bit more on the total weight, etc., and some of the drivetrain, it is possible in principle to save 60% of the fuel in cities. And today, and if you have alternative fuels with hybrid, you can save a lot of fuel. So alternative fuels with hybrid would be more friendly to the country as well as the economy. I think the undercurrent for any vehicle to be successful is not just how social the vehicle is, but also how economic it is to the ultimate user. So in that fashion, a hybrid vehicle with alternative fuel like CNG would be more economical for in the run up to say 2040 or something like that. By that time, more innovations should make electric vehicles a lot more attractive. But today, sorry to say this, electric vehicles are not so friendly to the environment as well as to the purse. The batteries also last only 4 years. After that, we have to use it for some static purposes. We cannot use it in the vehicle. That is today's status, in my opinion, as per my reading, etc. But that will take 10 years to mature for the electric vehicles. Till then, I think we should bet on hybrid vehicle with alternative fuel. So there will be still electric motor, there will be still a battery, etc. But the battery will be very small. Instead of 25 kilowatt hour, you may use half a kilowatt hour. Same lithium battery can be used. So this is my learning and as well as the view also. You can counter it, Shankar.
Yeah, no. I'd actually build on what Dr. Pal said. So if we want to confidently say that EV is a clean and green mobility option, we have to ensure three things. First is the electricity that we use for charging the EV should come from renewable sources. That's very clear from what Dr. Pal said. Second is, he said these batteries should be reusable, recyclable and reusable so that we are not really misusing the available critical materials. We are using it in a very responsible manner. The third, the economic part of it, sometime back, the cost of storing electrical energy in a lithium-ion battery was more than $1,000 per kilowatt hour. And the tipping point is $100. Once it becomes less than $100 per kilowatt hour, an electric vehicle will become more economic than an IC engine vehicle. You know what? We are very close to the tipping point now. Maybe we are at $120, $125. So we have come a long way from 1,000 to just very close to this tipping point of $100 per kilowatt hour for the lithium-ion battery. So the storage, the way the chemistry and the technology, the manufacturing of battery, the way it evolves is also going to accelerate this transition. So EV is not just a magic that you can solve everything in one product. It's more of a complete ecosystem. We have to look at everything around the EV to make sure that it's a really sustainable option that we are pursuing. Very fair.
Yes.
Excellent response from both of you, sir. Thank you. And just state about EV service and the charging stations, sir.
Last question.
Yes. There is a part in this story where Dr. Bharat finds out that people are worried not only by the range anxiety, but also by the lack of charging stations. Then he goes around, talks to people, Dr. Sharma, Professor Murugan, to see how this can be addressed. And then there is this very nice reference to Elihu Goldratt's book, The Goal, where the theory of constraints concept was introduced to say that it's not that it's just the lack of charging stations, but the long waiting that you have to go through when there are very few charging stations. So how do you keep the customers engaged when they are waiting for the charging station? What else can they do during that waiting time? So this puts Bharat in a totally different direction of thinking. Rather than just talking about fast charging, he starts looking at newer ways to solve this problem, inspired by the theory of constraints concept that he picks up from this Goal book. Then we have a small story, how he goes about applying those concepts to actually come up with a very practical and a very low-cost, effective solution for addressing the charging problem, especially during the early days when there are very few charging stations network. So I would encourage you to read that part of the book, because that's something that Ram wrote a very beautiful story around this theory of constraints to say how you can pick up very real life problems and apply this to quickly come up with very innovative solutions.
Thank you, sir. Thank you very much for your valuable time. Now I request any other questions from the participants? You can unmute yourself and ask. Okay, no questions. Now I request our chair, Maithili Prakash ma'am, to propose the formal vote of thanks.
So before that, Dr. Shankar, can you move the book to her left? Okay, and yeah, okay, fine. And Mrs. Chandran, can you come on video? Okay, Komati, Akila, all of you can switch on the video. Akila, so that I can take one. Yeah. Okay. I'd like to take one. Just a quick snap. 1 minute, huh? Okay, fine.
Thank you.
Thank you, sir. Thank you. Usually we used to do that after the meeting group photo. I recollect that scenario now. First of all, I want to congratulations Dr. Shankar and Dr. Ramachandran. It's an excellent title, Skilling and Business Opportunity in CASD Vehicle. It's a need for the day, rightly said. Thank you, Dr. A. Lakshminarayanan, for your details about the automobile industry and your journey. It's quite interesting. Thanks for sharing with us. So, looking for a day to discuss with you more on this. Good to know about the performance of multiple motors, that really innovative thought for a vehicle, multiple motors. Sounds good. Thank you, Dr. Chandran Krishnan. Your questions help us to elaborate the information about electric vehicle. A to Z, everything is covered. As initiative for everyone, the thought of starting a new entrepreneurship. This good to know about this Bharathan theme is really excellent. The way you have taken, which made Mr. H.R. Mohan sir to get that idea of creating movie. Yes, through this, really it will reach youngsters very much, because you have taken a lot of effort to put everything in a book, A to Z, that it should reach that community very well. Thanks a lot. Thanks all of you. Thanks for choosing our platform for your book release. We are really happy about it. Thanks for the joining society, Hindustan Chamber, IEEE CS and ACM. Thanks to all the participants through Gmeet as well as through watching through YouTube streaming. Thank you, Mr. H.R. Mohan sir, for organizing and coordinating this event. It was very, very, very much interesting and a very knowledgeable session. Thank you. Thanks for attending.
Thank you, Mohan sir. Thank you, Dr. Pal. Thank you, Mr. Chandran.
Thank you very much.
Thank you.
Bye.
Okay. Bye.
Stay in touch. Thank you so much. Bye.
Bye.
I think from tomorrow, Dr. Shankar is going to be extremely busy with
Correct, sir.